In this video, we'll take a look at the standard normal distribution. This is the distribution that's created by taking any set of normally distributed data, turning all of the data points into z-scores, and then you end up with the normal distribution. So a distribution that has a mean of 0 and a standard deviation of 1. The reason we like to standardize them is because we have tools that allow us to analyze standardized data. We have the z-table in your packet of formulas, and there's also one in your textbook. Additionally, we can use our calculator. So in order to use the z-table, what we're trying to find the probability of has to look something like this. So the probability that the z-score is less than 0.81 has to be a less than to use the table directly. And what you'll do is first find the units place and the tenths place in the rows for the z-table, and then find the 100ths place in a column. The place where the column and the row overlap gives you your percentile. So the percentage of z values that are less than 0.81 is 0.7910, or 79.1%. In a moment, we'll do an example. So the first thing you'll need to do is you'll need to draw a normal curve, shade the area that you're looking for, label the mean, standard deviation, and boundary values, and then either use your z-table or use your calculator to find the appropriate percentage, and then go back and answer the question in context. Let's try an example. On the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. Suppose that when Tiger hits his driver, the distance that the ball travels follows a normal distribution with mean 304 and standard deviation 8 yards. What percent of Tiger's drives travel at least 290 yards? So first we will want to make a sketch. We'll draw the normal curve. We'll put the mean in the center, and then we'll add and subtract the standard deviation multiple times to get our kind of cutoff points there. And then we're looking for where 290 would be, and we want to find at least 290 yards, so we shade above that point. Next, we would use the z-score formula, and turn 290 into a z-score of negative 1.75. From here, you can either use your calculator or use the z-table to find the appropriate percentage. Here's the z-table from either your book or your formula sheet, and we had a z-value of negative 1.75, so here's the negative 1.7, here's the 5, and the place where they meet would be our z-score. But recall that these are for a less than problem. We want a greater than problem in this case, which means we would want the complement of this. So we would have to subtract the value that we found from our table from 1. We'd have to do 1 minus 0.0401. Whether we do it that way or use the normal CDF command on our calculator, either way we're going to get 0.9599. So then we'll answer our question, and that works out to about 96% of his drives were at least 290 yards. There is a separate video in your notes on how to use your calculator. Let's do one more example. This time, instead of finding a value greater than, let's give something in between. So what percent of Tiger's drives travel between 305 and 325 yards? So you would start off the same way. You would draw the same distribution because you have the same mean and standard deviation. But now the x values that you're looking for are different. They're 305 and 325, and we're shading between those. We would want to either use our calculator or turn both of those values into z-scores. If we're going to go by hand and turn them into z-scores, remember that you'll be given the value for this point and lower. So what you would do when you go to look up 0.263 is the larger one, you would be finding the area from here and down, which means all of this would be included as well. And then when you go and you look for the other one, that's from here and down. So that would give you this, what used to be white. So you would have to end up subtracting them to get our final answer if you were going to do this by hand rather than on the calculator. So using the Z table, we're looking for the 2.63, and that would give us 0.9957, and then we would want to subtract out the value for 0.13, which is the 0.5517. Either way, whether we use the table or we use our calculator, we end up with 0.4459, which then when we go to answer the question, that means about 45% of his drives travel between 305 and 325 yards.